Hello students, I hope you are good, well and fine, and today we will be learning about polynomials, and we will be seeing what do we mean by polynomials and their different formulas, their properties, and solve as many as examples we could, so that you can understood the concept of polynomials and how the question will frame in exams. You will be seeing all of that. So let's begin, or I just jump into our topic. So first of all, what is our polynomials? Polynomial is our an algebraic expression of the form a naught plus a1x plus a2x2 plus till a n x n, where we are saying that these a naught, these a1, a2 till a n are our real numbers, and all the index of x, that means power of x, that means this here is 1, the 2 till the n are non-negative integers. Then we called such expression as our polynomial in x. If you see other example, for example, this is my polynomial. The a naught plus a2 x plus a3 x square plus a4 x cube. Say a let's say a naught, a1, a2, a3 x cube. This is my polynomial. Okay, now for another example, if you are taking a naught, a1, a2 as my real numbers, so let's see. So 7x plus 9x square is also my polynomial. Okay, so I hope now you are clear that what do we mean by polynomials and how it is uh, represented, and what are my a naught, a1 and so on. This we call the coefficients of x. Okay, so the polynomial is in the term of x, and x is my variable, whereas coefficients of x are some constant number, such as here 7, here 9. I hope this is clear. So let's move to next. Now, degree of the polynomial. The main term in the polynomial is the degree of the polynomial. Degree of the polynomial means the highest power of x in the polynomial expression. For example, if my polynomial is given like this, 7x square plus 3x plus 2. So in this, if you see, the power of the x, or the maximum power for the x, is 2. So this means degree of the polynomial fx above is equals to 2. I hope this is clear. And if you take another example, so now let's say gx is my another polynomial with 9x4 plus 2x. This is also my polynomial, and here in this degree of gx is equals to what? So what is my highest power of x? This is my 4, which is equals to 4. Always remember, in previous you saw that the x power must be non-negative. This means uh, if you are saying that this expression x minus 1 plus 9x square, is this a polynomial? A polynomial? So we say the answer is no. Why? Because here the x value is some negative, but in polynomials, the index for x must be like 0, 1, 2, 3, 4, 5 and so on. Okay, I hope this is clear, but not -1, -2, -3. This cannot happen. Okay, I hope now you are clear. So this is an example of no, not a polynomial. I hope you are now clear with the how my polynomial will look like and how my polynomial will not be represented in this form. Okay, so let's move. So we are on this. So in this you understood the concept of degree also. Okay, okay, now let's see. Let's take a note. A polynomial in X is said to be standard form when terms are written in either increasing or a decreasing order of indices of X. For example, my polynomial is given such like this also. So this is my polynomial, yes, because all the powers of X are non-negative. Here X power is 1, here X power is 2. If you see, we know if I have a number or a variable power 0 always equals to 1, whereas X cannot equal to 0. So here 9 can be rewritten as 9x power 0. I hope this is clear. So in this case, if you write it down the increasing order, so here power is 1, here power is 2, here power is 0. So it is not in increasing order or neither in decreasing order. So first of all, let us arrange it in increasing order. So 9x1 plus 9x2. Then this form is my increasing order, and this we called it as a standard form for the polynomial. Okay, now if one can also write it down like this: the decreasing order of X indices. So this means the power getting decreased. So here the power are getting decreased. So this is also my standard form for the polynomial. Now you can get some idea that how my polynomial will look like, how my standard form of the polynomial will look like. Okay, let's move to next and understood more terms. Okay, so now how the different types of polynomials. So different types of polynomial, some polynomial based on degrees. For example, the linear polynomials. So linear polynomials have a degree 1. So degree 1 means my polynomial, the highest power of X can be 1 or must equal to be 1. Okay, so this means if you say my linear polynomial will look like ax plus b, where a and b are reals or real numbers, whereas x is my just a variable in polynomial. That means my linear polynomial in x is looking like ax plus b, where a must not equal to 0. Please give this as much as importance. Okay, so for example, for example, 9x plus 3 is my linear polynomial. 6x plus 2 is also my linear polynomial. 6x is also my linear polynomial. 100x is also my linear polynomial. Okay, but if you see, not linear polynomial is example is just a 6. If you see 6, 7, or say 6x square. Okay, why? Because here there is no term of like this a times x or any number times x. Okay, here also the same reason works, because in linear polynomials, the degree must equal to 1. Here the degree is not 1. If you see here, the degree, what is the degree? The highest power of x, which is 2. So degree for this is 2. That means, but in linear polynomial, the degree must be equals to 1. So here the degree, what I can rewrite it as like this, x power 0. So you can say the degree is not equal to 1. So here degree is not equal to 1. I hope this is now clear. So in linear polynomials means degree must be equals to 1. Okay, I hope this is clear. Now in quadratic polynomials, degree must be equals to 2. For example, my general quadratic polynomial will look like this, where a, B, C, this in here, this is the, I think x is missing, so this will look like something this, where a is non-zero. What if a becomes 0? Then if a is 0, this is 0 times x square plus bx plus c, that is bx plus c. So here if you see, the new polynomial will be my bx plus c, which is of the form ax plus v, that is a number multiply with x plus some constant. So this is of the linear form, because this degree is equals to 1. Okay, but in quadratic polynomials, degree must be 2. So any polynomial whose degree is 2 is my quadratic polynomial. For example, 2x square, yes, it is my quadratic polynomial. Say 2x square plus 4, it is also my quadratic polynomial. 2x square plus 4x plus 10, it is also my quadratic polynomial. I hope this is clear. Let's move to next. Now the cubic polynomials. Here, as the name suggests, cubic means the degree must be 3. So degree, if a polynomial having a degree 3, we called cubic polynomial. In general, cubic polynomial will look like this: the ax cube plus bx plus cx plus d, ax cube plus bx square plus cx plus d, whereas the a cannot equal to 0. What if a is 0? If a is 0, this term get equal to 0, then my cubic polynomial will not remain cubic, it will become a quadratic or a linear or just a constant, because it depends on coefficients. So the one thing is to remember is just the degree must be 3, then my polynomial, I am saying it as a cubic polynomial. For example, if you see an example, say 3x cube, this is my cubic polynomial. 3x cube plus 3x square, this is also my cubic polynomial, because in all the polynomials my degree remains equal to 3. The degree means the highest power for x. So not cubic, is example is just 3x square, it is not cubic. 3x4 plus 3x cube, if you see the degree for this expression or for this polynomial is equal to 4, because the highest power for x is 4. So the degree is equals to 4. So degree is which is not equal to 3. This means my this polynomial is not cubic. I hope this is clear. Now biquadratic means the degree must equals to 4. Okay, so degree must equal to 4. In general, biquadratic polynomials will look like this: ax 4, bx cube, cx square plus dx plus e, whereas a must not equal to 0. What if a becomes 0? Then my term or my polynomial will reduce to just a cubic polynomial, because this term will be equals to 0 if a is 0. I hope these all types of polynomial on basis of degree. So we segregated types on the basis of degree. As you saw, in linear degree must be 1. In quadratic degree must be 2. In cubic degree must be 3. In biquadratic degree must be 4. There's a note which says a polynomial of degree 5 or more than 5 does not have any particular name. So such polynomial usually called as just polynomial of degree 5 or degree 6. For example, 6x power 5 plus 6x power 4 plus 6x power 2 plus 6. This is my polynomial. If you see degree, what is the degree? Degree is the maximum or the highest power for x, which is equals to 5. So degree, this is my polynomial of degree 5. So I will say that this is my polynomial of degree 5. I hope now this is clear from an example. So let's move to next. Now the type is based on number of terms. So previously we talked about the polynomial on the basis of degrees. Now we will talk about on the basis of terms. So what do we mean by terms? So in polynomial, we know my polynomial will look like this: a n xn plus a n minus 1 xn minus 1 till a 3x cube plus a1 a2 x square plus a1 x1 or just x plus a naught. This is my standard form of polynomial in decreasing order, of the indices of n. So as you see, these power for x is reducing or decreasing. Okay, so this is my standard form for the for a polynomial in decreasing form. So now what if these we all know these an minus 1 a3, all these a's are coefficients. Okay, and this polynomial is in term of x. So polynomial in x, so this is my variable. This could take any value. Okay, depend on the polynomial. Okay, so now what? Now okay, now this whole the coefficient and the x power n will I say this is my term, or say nth, or the nth plus 1th term in the polynomial. This term is the first term or the last term. I am seeing backward. So if you see that this term is my first term in the polynomial, this is my second term in the polynomial, and this will be my last term in the polynomial, because the polynomial given in decreasing order, if it is decreasing in if it is given in increasing order, then this term will be my first term, this term will be my second term, and so on. I hope this is all clear. So now in monomial polynomial, the monomial polynomials are having only one term. So any polynomial with only one term, I will be calling it as monomials. So for example, x 9x square 5x cube. So for example, if you see, is this my monomial polynomial? So no, because it has two terms, one is this and second is this. I hope this is clear. So terms are separated by plus or minus sign. So terms are separated by plus or minus sign. in polynomials. I hope this is clear. So if you see, here is my plus sign, and to right of the plus sign there's one term, and to left of it there's another term. So it has two terms, 1, 2. So it is not an example for monomial polynomials. In binomial polynomials, that this means by means 2, so this means by name. In binomial polynomials, it contains only two terms, so only two terms. In binomial polynomials we have only two terms. For example, 2x square plus 3x, so one term is this, second term is this. Another example is this, root 3x plus 5x cube, and another example is this, minus x cube plus 3. So one term is this, another is this. All are binomials. Okay, I hope this is clear. Now in trinomials, as the name suggests, tri means 3. So a polynomials containing only 3 terms, we will call it as trinomials. For example, 3x cube minus 8 plus 5 by 2. So one term, the second term, and the third term. So root 7 x power 10 minus x power 4 minus 3x power 2. So first term, second term, and the third term. And this is as you can see, the first term, second term, and the third term. So this is also an example for trinomials. I hope this is all clear. Now there's another note for this these types on the basis of terms, that is, a polynomial having 4 or more than 4 terms does not have particular names. Okay, we just say polynomials. Okay, let's move to next. Now the on the basis for degree, if you see, there's another type which is 0 degree polynomials. That means polynomials whose degree is 0. That means just a constant number. For example, fx is, if fx is my polynomial, that means say 9, and 9 I can rewrite it as x power 0, because any coefficient or a constant number power 0 is equals to 0 if that number is not equal to 0. So here I am taking this x not equal to 0. So in this case the 9 x power 0 means just 9, and so this means the degree for this is 0. So this is an example for 0 degree polynomial. So my 0 degree polynomial will just look like a constant number. So fx is equals to 9, just a constant number. Fx is equals to 100, just a constant number. And you can create whatever you want a 0 degree polynomial. I hope this is clear. Now 0 polynomial, don't confuse with 0 degree polynomial and 0 polynomial, because in 0 degree polynomial we are talking about the degree of the polynomial must be 0, that is x raised to the power must be 0, or my polynomial is just a constant number, and whereas this constant number cannot equal to 0. The one important point to mark is that my polynomial must be constant but not equal to 0. For example, if my polynomial is just this, so yes, indeed it has the degree 0, but this is not a 0 degree polynomial, because in 0 degree polynomial we are taking such constant numbers which are not equal to 0. So the one condition is that my constant number will not be equal to 0. So this is not a 0 degree polynomial. I hope this is clear. Now in this case, 0 polynomial, this means my A polynomial whose coefficients are zeros is called zero polynomial, or just fx is equals to 0. This is the only zero polynomial. We cannot determine the degree. So in this case, we cannot determine the degree. Okay, I hope this is clear. Okay. Okay, because why we are saying that we cannot determine the degree? So in order to determine the degree of the polynomial, you must give in that the highest, first of all, the highest power of x, uh, say here, say 5, and the coefficient must not be equal to 0. So these are the two conditions for to find out the degree. If one says what is the degree for this 0 times x power 5, so don't write degree is equals to 5, because this condition does not follows, because the you say yes, the maximum power is 5, but the coefficient must not be 0. Here the coefficient is 0, so degree is not equal to 5. We say in such cases degree is cannot be determined. Okay, I hope this is clear. This is also a major point. Okay, always if you are finding out a degree for a polynomial, always do two things in mind. First of all, the maximum power, and the coefficient for that maximum power of x must not be equal to 0. So then only you be able to find out the degree. So here not a 0 degree polynomial. So in this case, the a degree cannot be determined. So degree cannot be determined. Okay, I hope this is clear. So let's move to next. Now let's see some algebraic identities. So first of all, what do we mean by identity? Identity are those expressions on left and right hand side of the equal, which always true. Okay, for example, we know 2 is equals to 2 is always going to true. Okay, and if you say that 4 square is 16, so this is also true. And in general, a plus b is also is equals to b plus a, is it is also a kind of identity. And the some other identities are given here. For example, a plus b whole square is equals to a square plus 2ab plus b square. This always going to happen. Okay, I hope you are clear what do we mean by identities. Now second is a minus b whole square is equals to a square minus 2ab plus b square. Third point is a square minus b square is equals to a plus b, a minus b. Fourth one is a cube plus b cube is equals to a plus b. Multiply with a square minus ab plus b square. Please do remember all of these, because in the concept of polynomials, these identities are too much important. Okay, so without these identity you will fall behind. Okay, let's see more identities. Okay, the fifth identity is a cube minus b cube is equals to a minus b, a square plus ab plus b square. The sixth one is a plus b whole cube is equals to a cube plus b cube plus 3ab, product with a plus b. And seventh property is a minus b whole cube is equals to a cube minus b cube minus 3ab, a minus b. And the eighth one is a power 4, a square b square plus b power 4 is equals to what it equals. It is equals to a square plus ab plus b square, a square minus ab plus b square. I hope now this is all clear to you. Okay, so these please do memorize them, as you can get so much benefit out of it. I hope Now I am leaving it here for today. Let's meet again, and in the next lecture I'll be starting with these properties, and I hope that you will going to memorize them, and then we discuss many problems on these identities, so that you can have some idea that how we are going to approach follow our approach on the basis of these identity, okay, and how to solve the given problems as quickly as possible by just using these algebraic identities. Okay, let's so that's it for today. We will be meeting in next. So thank you.